Hello, my name is Piero, and I would like to talk about my first and most exciting research experience, cell culturing a biomaterial made of pectin and alginate. So let's start with some facts. It is known that some people require some tissues or organs transplants, uh, either by the loss of functions, diseases, accidents, or maybe congenital problems. But obtaining these tissues or organs from a donor brings with it some other problems, such as non-compatibility or rejection by the receiving body. To avoid these problems, the scientific community has developed a very promising field, 3D bioprinting. The principle is simple: to print a 3D scaffold and culture and make a cell culture in it with the patient cells, so the cells can grow and replace the bioprinting with living tissue. Then you transplant the tissue inside the body of the patient, and since they are the same cells of the patient, we no longer have the problem of the no compatibility. uh, However, there is still a problem: the cost. The bioinks available in the market are really expensive, so the objective of the project was to develop a bioink with the same physical and structural properties, biocompatibility, but made with low-cost materials. After a year and a half of work, we finally made a bioink with those properties, made of pectin, alginate, and collagen. The biocompatibility was measured with a biotoxicity assay, and the bioink keeps its shape after cross-linking with calcium chloride to make it solidify. But a long time project also means a long time having problems. The first was the loss of an entire cell line of HCC 70 cells due to our inexperience. We didn't have money to buy another cell line, so I proposed to use the mononuclear cell of my blood. And the first 5 cultures got contaminated before we did it right, but we finally learned how to work under sterile conditions. Uh, Throughout the rest of the project, there were always problems. The bioink was too acid. I proposed to use calcium lactate to do the cross-linking. Uh, the scaffold took off after doing cross-linking, so I proposed a collagen bed to help the bioprinting to get fixed. Um, so many times I had to take the role of the team leader, almost always after something went wrong. Some students left the projects. Uh, Currently, I am the only one of the team that started the project that is still working in it. So every time a member leaves the team, I had to call for other students that are interested in the project. Um, this made me grow and develop a very strong sense of responsibility. The project is still on course, and now the team is working with chicken fibroblast to see if that kind of cell could proliferate inside the bioink. And we are training another team of 5 students working with 3T3 cells to repeat the biotoxicity assay. Being part of this project, I learned a lot about cell cultures, biomaterials, how to read and understand papers, how to do a research, but most important, I learned to never give up when things go wrong, because it's these moments when the team needs you the most. It's okay to fail. It's just another way of learning. Thanks to failing, I learned to be patient, to do project planning, to stay curious about the future, uh, and to build strong teams in my current project. Uh, so finally, this project definitely was an amazing experience, enriching my skills as a student and as a person. Finally, thank you very much for choosing me in the first stage of the REPU program. Uh, I hope to see you again. So, see you later.